All right, let's take a look at some probability. This is a conditional probability question. A virus infects 1 in every 200 people. A test used to detect the virus is positive 80% of the time if the person has the virus, and it's only positive 5% of the time if the person does not have the virus. That's a false positive. So with numbers like this, I like to take, so 1 out of every 200, let's just say the population. What would happen if we had a population of 200,000? A population of 200,000. Then 1 in 200, that would be 1,000 and 200,000. Just multiplying by, looks like just 1,000 on both sides, and we get this. Okay, good. So what we know is in a population of 200,000, a certain virus would have infected 1,000 people. So we have 1,000 infected. That leaves 109, I'll get there, 199,000 not infected. And there's our 200,000 people. All right, now, a test used to detect the virus is positive 80% of the time if the person has the virus. So 80% of this will be 800. These are 800 test positive. The other 20% of the time, the 200, these people that are infected will test negative. So these are true positive, and these are false negatives. Now, of the 199,000 that are not infected, we have that 5% of the time they'll be tested positive. So now I'm going to a calculator and multiplying that by 0.05, that number, and we get 9,950. So although these people are not infected, the test makes mistakes. 5% of the time, it'll count someone that does not have the virus positive. That's those people. And if I subtract that number from the original 199,000 that were not infected, I get the rest of them, 189,050 people, test negative. These are false positive, and these are true negative. Okay, so these are the numbers we get to work with. Find the probability that a person has the virus given that they have tested positive. Okay, so tested positive. We have the 800 people that had the virus that tested positive, and the 9,950 people that are not infected that tested positive. That is a total of 10,750 positive tests. Okay, so find the probability that a person has the virus given that they have tested positive. So given that they have tested positive, so this is the probability of A given B, this first question. The total number is this 10,750. That's how many people tested positive. What's the probability that they have the virus? Well, only those 800 out of that 10,750 have the virus. So we work this out, and we get 0.0744. That's the probability. And now we can also go to 7.44%. And this question asks for the nearest tenth of a percent, so that would be 7.4%. So this is a surprising statistic for people. This, if you tested positive, you only have a 7.4% chance that you were actually infected. And the reason why is all the people that are not infected, the test made a big mistake. Actually, it's a small mistake. It's only 5%. But it gave us a whole bunch of people that tested positive falsely. So of the population that tested positive, not many of them actually had it. Small percent. Next question. Find the probability the person does not have the virus given that they test negative. All right, so for this we need the total negative tests. So we have the 200 of the people that were infected that got a negative, and the 189,050 that were not infected that tested negative, and that total 189,250. So the probability, that the person does not have the virus, so if A is they have the virus, that's the opposite of that, not have the virus. Given that they tested negative, the denominator is the total number of people that tested negative, and the probability that they do not have the virus, most of those people do not have the virus. So we divide these numbers out. And we get 0.99894. So that's 99.9%. All right. Now, this information is often put into a table. So let me just demonstrate this table. Not drawn very nice. So let's see, we have 3 columns and 3 rows, and this is test positive, test negative, total, and infected, not infected, and total. So the grand total, we're working with 200,000 people. Infected, we worked out that there's 1,000 total people infected. And that gave us the rest of the people not infected. The positive test, so the people that are got a positive test, we worked out 800 of them that are infected got a positive test. The other 200 did not. Of the not infected, we have 180, positive tests. 9,950 got a positive test. And the rest got a negative test. We've added these two together, and we got 10750. Those are the total positive tests. And we added these two together, 189,250. Those are the total negative tests. So this is a nice way to work out the information, put it into a table, so that if we have the probability of positive test given infected, for example, the given infected, how many people are infected? 1,000 people. What's the positive test? 800. That gives us our 80%. But the other ones, given that they're infected, given that they have a positive test, the positive test, how many people had a positive test? All of those. And how many people were infected? Just those. So we can work out all the different conditional probabilities working with this table efficiently. So you get to choose whether you want to work out the numbers and just kind of list them as I did, or put them in a table, either way. What really makes this problem one that's not very difficult to do is to create a population based on the original numbers, 1 in 200, or 1 in 200 people infected. So I just multiplied 200 by a couple of zeros. In this case, I gave 3 more zeros, and it gave us a nice population to work with, so we have nice numbers. If you look at all the numbers, every number has a 0 at the end of it. So we actually could have worked with 20,000 and still had a whole number of people. But I go into the 100,000 range when I do these problems. All right, I hope this helps.